Okay, use your scratch paper to follow along with the Math on the Spot video, Chapter 10, Lesson 2. Follow along.
Finding the area of triangles really is not that big of a deal. It's just 1/2 the base times that perpendicular height. In fact, if the triangles are right triangles, so one of the angles is actually a little right angle, then it's really easy. It's just literally 1/2 the base of the triangle times the height of the triangle. And really, that's just because, if you think about it, one of those triangles is just half of a rectangle. And you know that the area of a rectangle is base times height. And so half of that would be 1/2 base times height. Let's take a look at an example where we can see two individuals trying to make meaning of this basic formula. Basic, not easy. Basic, meaning fundamental and important. Let's check it out for ourselves. Okay, so Cindy and Tyson drew models right here. And each claimed that their drawing represents a triangle with an area of 600 square inches. The question for us is, which statement do we believe, and which statement maybe is not so perfect? So in each case, each person is claiming that their model is representing a triangle having an area of 600 square inches. And so I should make it clear that this is a claim. So each triangle has, maybe I should put them in little quotes here, has, because maybe they don't each have. So it's kind of like a question mark. Let's see if that's right or not. So that's the statement. Okay, well, let's start with Tyson's model. So here's what Tyson drew. You can see here is the right triangle. That little angle in there being a kind of a right angle shows me that that's a right triangle. So we can see it's actually, you can visually see it's half of a rectangle. So it's not surprising that we have that beautiful, important formula, which basically says that the area of a triangle, the equation is 1/2 times the base, which I'm going to call B, times the height, that perpendicular height, which I'll call H. So again, these are the independent variables, and once I have that, the area will pop out, and that's the dependent variable. So there's the nice equation that we get. So in this case, you can see that in Tyson's model, this is the base, and so therefore in this case, the B would equal 30. The height, which is that perpendicular length against the base, would be 40. And so how would we, if we put in B 30 and H 40, then what does the equation give us? Well, then the area, which is dependent on these other numbers, would be 1/2 times 30 times 40. So what is that? Well, 1/2 times 30 is actually 15, and 15 times 40 is actually equal to 600. Ha! 600, and the units are inches multiplied by inches, which we can write as inches squared. So this looks good. So I'm liking this. This is a check. This is a check. Bing! So this actually works. Bing! We get 600 inches. Now let's take a look at Cindy's model, which I really like. It's very pretty. Let's see, though, if it gives us the right area. So let's see. In this case, we see that this is the height, and so that's actually the height, and that's 30. And what about the base? Well, the base would be this length, which would correspond to this length right here. Oh, but wait a minute. We don't know that length, right? All we know, in fact, is that this length, this diagonal length, is 40. But that's not the height. That's not the height, and it's not the base. In fact, it's neither, because this represents the length of the base, same thing as this, and this represents the height. And so, in fact, we don't know what the base is. So, in fact, that's something we don't know, but we know it's not 40. But I know the base is not going to equal 40. How do I know that, by the way? Because if you look at this right triangle, you can see that this side that's opposite that right angle, which is sometimes called the hypotenuse, that's always going to be the longest side, always. Which means, and notice this is 30, and this is certainly smaller than this, which is 40. And you can even visually see it. You see that if you kind of took that length and just flipped it around, it would be a lot longer than this. So this is going to be less than 40. This is going to be less than 40. So whatever this number is, it's not 40. It's going to be smaller than 40. So when I actually put in the 30 and 40, and I'm sorry, when I put in the 30 and the number smaller than 40 into this thing, we'll get a number smaller than 600. So in fact, here we could say the area is actually going to be less than 600. The area will be less than 600, which means that the area is not going to equal 600. And so that means that, in fact, while I really do like what Cindy did, it's a great example of showing us that, in fact, we're not going to get 600 for the area of this, because this is not the right length that we need for this area equation. We're going to need the height and then the base, which is equal to this top part here, which we don't have. And in fact, we know for sure it's not going to be 40. So that's really wonderful that Cindy was allowing us to actually really get a deeper understanding of what this means, what it means to find out the area. So I love that, and we should thank Cindy. And we see that in terms of the question at hand, we see that the area of Tyson's model is 600 square inches, or we can write 600 inches squared, and that's great. We can see the calculation, and maybe even greater, Cindy teaches us a valuable lesson that when we're looking at triangles, even when they're kind of like this, we have to understand that the base and the height have to be those edges that are perpendicular to each other. Really important to understand what to look for when you're finding the area of a triangle. When we say 1/2 base times height, we have to understand that that height has to be a perpendicular height with respect to the base. Once we have that, we're good to go. Have fun finding the areas of triangles all around you. You're now equipped to do that, and I'll see you soon.
All right, thanks for watching, and continue on your lesson for today, 10.2.